next question is, we did that one, 51. You may. Alright. 51. Oops. Oh, I love this question too. I love all these questions. I feel like I'm being really disingenuous, but I really do like them. I think they're fun. Alright. How many of you got a little stuck on 51? Like going, whoa, that's kind of scary. Because there's a lot of stuff going on, right? This one is doable, but this may be, this one and 59, like 58, 59, like all these car problems are kind of tricky, but we can do them. All right. I'm going to read it out loud so we know what we're doing. The speeder passes a parked police car at 30 meters per second. The police car starts from rest with a uniform acceleration of 2.44 meters per second squared. How much time passes before the speeder is overtaken by the police car? Now, before we get too far into this life lesson, if you are driving a little too fast next to a parked police car and the parked police car starts to follow you, you don't continue at the same speed until the police car reaches you, okay? Don't do that. That's not a good plan. You need to slow down. But to make this problem a little simpler, because it doesn't say that the guy slows down, or gal, I guess, doesn't say the speeder slows down. We're going to just assume that it's at a constant speed. Does that make sense? Don't do it. How many of you are driving already? Any of you? Yeah, don't do that. Like, you'll be like, my physics teacher said this was the... No, that's not good. Okay. How many objects do we have in this problem? Do you notice a pattern here?
Yeah.
All these two object problems. Okay. So we've got the police car. And we've got the speeder. I'm going to give you a moment to write down the givens for both objects. Go ahead and do that. Talk to your neighbors. Work together. Write down the givens. Do it right now. Go, go, go. Many of you have been silent. In 5 seconds, I want you to talk. For real, I want you to talk through them. Go. Talk, 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 talk. Compare. Or at least look at each other's things so you can see. Okay. Hey Zoe, how did your lists go over there? They go okay? Yeah? Can you tell me one of the things that you wrote down? Awesome, thank you. All right. Let's see. Kayla, go. And that's the one that we say, don't do that. That's really bad. They don't like that. They don't like that. All right, Max, did you write another one down?
Yeah.
What'd you get?
The velocity of the car was...
Of the speeder?
Yeah.
Okay.
30 meters per second.
Excellent. Go.
VI for the police car is 0 meters per second.
Awesome. Were there any other givens that anybody wrote down? Yeah? What else did you write down?
The final velocity for the police car is going to be 30 meters.
How did you come up with that?
speeder, which is going 30 meters a second.
Okay.
And for part A, you have to figure out when he gets to the same speed.
Okay. Okay. So I want to talk through that for a second. So if I have the police car here, and I have the speeder here, and they start at one spot, and they're going to travel such that now the speeder is going to be here, and the police car is here. Whoa, I guess the police car kind of swerves, but you get the idea, right? If he's only going 30 meters per second, is he ever going to be able to catch up to this one? This is something that a lot of people tell me this, that should be 30 as well. But if this one is traveling at 30 meters per second the whole time, let's say they traveled 10 meters, okay? I don't know why I said that. Well, I guess we can find out how long it took, right? Would this one have traveled the same distance if it only gets to 30 meters per second?
No.
No, it's not quite possible. Does that kind of make sense?
Yeah.
So this one actually is going to have a final velocity that is bigger. So I'm just going to change that to greater than. Is that okay? We don't know what it is, but we know it has to be greater than. Now, does anybody else have anything else written down? Let me ask a question. How do the distances for the speeder, or the displacements, for the speeder and the police car compare? How do the displacements for those two people, for those two objects compare? If they both start here, and they both end here,
They're the same.
does it make sense that they're the same? I'm going to say that the displacement for the police car has to be equal to the displacement for the speeder. Yeah, what's up?
It says when the police car overtakes the speeder, so
Mhm.
it would be greater than.
Well, so we're talking at the very moment, right when that passes. And then beyond that, I mean, hopefully he doesn't just go by, right? Does that make sense? So it's a really good question because the overtakes is like, implies that it's going just a little further. So let's just find that place where they actually line up. Yes, yeah, good question, good question. I have a question for you. Have you ever experienced a real life situation, not being chased by a police car? That's not what I'm asking. I don't need to know that information. Like maybe even in this room that looks kind of maybe something a little bit like this.
Oh my gosh.
Right? The ball in the car. It's like the ball was the what?
It's the police car.
The police car. Whoa! And the little red car is like the speeder. And they travel the same distance in the same amount of time. This one does not accelerate. This one does. Is that making sense? So you've really done this. I mean, this is the same thing. Yeah. You sure? Okay. If you think of it, let me know. Okay. So here's the thing. This right here is the key to this whole problem right there. Okay? It says how much time passes, so we really want to know the time. How does the time for the police car to get from here to here compare to the time for the speeder to get from here to here? It's the same, right? So we know that the times and the displacements are the same. Oops, not D. That would be bad. Come on. There we go. Do we have an equation? Do you notice that I ask this all the time? Do we have an equation? Do we have an equation? That's what I want to know. Do we have an equation that has these 4 things in it? Take a look. Take a look. See if you can find one. Once you find one, put your finger on it. Compare with your neighbor. Have we seen this equation before?
Yeah.
Over and over and over. It will become your favorite because we're just going to keep using it over and over and over. What equation did you choose? Who haven't I talked to lately? I don't know. Sydney, I haven't talked to you lately. What equation did you choose? Awesome. The big, long, scary one, right? Does everybody agree? Yeah. So here we go. We're going to do something wild and crazy again. Do you remember this? We did this before and you were like, It was crazy, that was crazy. And then things worked out. So we're going to do that again. We're going to try it again. I'm going to say dp, I'm just rewriting this, is equal to ds. And then instead of writing d, I'm going to write the big long scary thing. Oh no! Here we go. Vi for p times time plus 1/2 the acceleration for p times time squared is equal to. Oops, I'm going to make that green. Did I do that right? Yeah. And then, what color did I use the other one? Purple? Vi for the speeder times time plus 1/2 the acceleration for the speeder times time squared. Well, that made it look simpler. Thanks, Ms. Carmeline. All right, looking at your givens. Do any of those things get to go away? The answer is not no. The opposite of no would be?
Yes.
Okay. Raise your hand if you can tell me. Ooh, ooh, ooh. One of the things that goes away. Connor, what do you see that goes away?
VIC for the police.
For the police car, right? Well, that's gone. That's nice. Anything else that goes away? Go, Tay, what do you see?
1/2 AST squared because we can do it.
Right. Well, now it does look a little bit better, doesn't it? Now we've got 1/2 of the acceleration times time squared is equal to VIS times time. And we're trying to solve for the time. We've got one that's squared, we've got one that isn't. But that means that there are going to be two solutions. I'm going to unwrap that math skill just a little bit here. There are going to be two solutions. One of the solutions is if time is equal to, if time is 0 here and time is 0 here, then this thing turns into, and this thing turns into, and that means that they're at the same spot. Does that make sense? Because that's where we started it. Okay? The other option is way over here, and we can find that other option by dividing by a t. Can you divide by t on both sides? Well, yes, I can. Boom, boom, see ya. And then you can solve that problem. True? Do it. That's like the best face I've seen all day. Tell me what you're thinking, Renee. Can I, what's that? You're going like, I can't solve that. Is that how you're feeling? Okay, let's rewrite it. Yes, you can. I believe in you. Here we go. So I've got 1/2 AP times T is equal to VI for the speeder. Can you get the T all by itself there? Yeah? What am I going to do first, algebra-wise? Getting T all by itself. I need to undo, this is a dividing by 2, right? So how do I undo dividing by 2? Multiply by 2. And then I need to undo multiplying by A. How do I undo that? Divide by A. All right, go, go, go. Find out your answer. Once you've got an answer, check with your neighbors, see if they agree with you. And then take a look at part B and see if you can do part B now. What'd you get?
24.6.
24.6? Okay. Is that okay? Good. Liam, how you doing back there? You happy? Good. All right. If you look at part B, it just says, how far did the speeder get? Can you do that part now?
You have to grab the time.
Liam, you're dumb. Or not Liam.
No, don't say anybody's dumb. That's not nice at all.
Yeah.
You have the time. You have the acceleration, you have the velocity. Can you find the distance? Yes. Yes, you can.
Oh, wait.
Okay. The next one we're going to look at is, that was 51, 54. So take a look at number 54.